Heyo, we talking about average value. All right, this uses a lot of what you already know and a little bit of what you don't know. All right, so let's break it down. First, they give us our definition of mean value theorem for integrals. Okay, you already learned MVT about derivatives. That's when the secant equals the tangent. All right, so now I have a mean value theorem for integrals, and the idea is kind of similar. So if we break this down, this is my formula for the height of a rectangle. Okay, so f of c, this is my height, and then b minus a, this is my width. All right, so same deal. We've been dealing with rectangles this whole unit. We're still dealing with rectangles. Now I can rearrange this a little bit into a form that you're maybe a little bit more familiar with. Okay, I could solve for f of c. And that's going to be the integral from a to b, f of x dx divided by b minus a. And now this is essentially what you've already done for average for your whole life. Okay, so normally when you do average, it's like your stuff divided by the number of stuff, right? So if I'm averaging like how much money me and two of my friends have, it's like it's my money, so say I have 10 bucks, my friend has 11 bucks, my other friend has 12 bucks, and then there's three of us. Right, it's the same deal here. So keep in mind what you're doing here. This is my area over an interval. B minus A is my interval. Okay, so I'm finding the average value of my area for one of those rectangles. I'm just trying to find the average of like one of those rectangles if we did a Riemann sum. Now, a different way of writing this is to stick the 1 over b minus a in front, and this is the way you'll normally see it. So it's your normal integral with a 1 over b minus a in the front. That's the only extra step that you have to remember. Now, let's see what this means graphically. Right, so if I have some curve, right, say it looks like that. All right, and we'll draw the same curve over here. That's supposed to be the same curve. Now, what I'm telling you is that from A to B, right, we have some area, right? So we have, some area. Now, there will exist some C value here. Now, I don't quite know where this C value is, but it's somewhere. Okay, it definitely exists. And what I'm telling you is that if I create, I'll actually erase this. So if I create a rectangle with this exact same C value, so using the height of my C value, so this rectangle right here, what I'm telling you is that this rectangle has the exact same area as the area under the curve. Okay, so there will be some perfect rectangle. There will be some value of C that will make a rectangle that has an exact area as the area under your curve. Okay, that's what the mean value theorem says. And again, the way that we find that is just by taking the integral from a to b of f of x dx and putting a 1 over b minus a in front of it. So again, this is really just finding average. Okay, but what it does is it gives us a really cool rectangle. It turns my integral under a curve into a perfect shape, a perfect rectangle. Now let's actually practice an example. So they give me a function and an interval. They want me to find the average value, right? Easy peasy. So my average, again, is just 1 over b minus a. So 2 minus negative 1, that's 3. Integral negative 1 to 2, 1 plus x squared dx. The only extra thing right now is this 1/3. Okay, so I take the integral x plus 1/3 x cubed from negative 1 to 2. Okay, I do the first fundamental theorem of calculus. So I'll have 2, and then what's that? 8/3 minus negative 1 minus 1/3. Okay, so I get 2. So what this means is that 2 is the average value of my function between negative 1 and 2. Okay, so if I made a rectangle with a height of 2 and this stuff, then it would be a good thing. Okay, so now I actually want to find the C value. So keep in mind, what we found here is like a Y value. I want to find the X value. So my average is equal to my Y value. So I'm just going to plug this in for Y. Okay, I'm not going to plug it in for x, I'm solving for x. C is always an x value. So 2 is equal to 1 plus x squared. So x squared is equal to 1, so x is plus or minus 1. Now, negative 1 is one of my endpoints, so I'm going to disregard that and just say x equals 1, and that is my c value. Okay, you could have used c instead of x, it doesn't really matter. Okay, that's the c value that I wanted. So what's happening is if I sketch my graph here, so this is a parabola shifted up 1, from negative 1 to, say, 2. Okay, so there's all this area here. Now, if I make a rectangle at 1, so it should just about, what I'm saying is that this area here in this rectangle is the equivalent to the area that's under this curve. So basically this area right here and this area right here should about even out. Now it doesn't look like that because I drew a bad picture. I'm not good at drawing, but on an actual graph it should even out. Alright, now let's do a table. Right, let's do a left Riemann sum to find the average value. Alright, so average value between 5 and 17. So I would set up my integral like so. Now I don't know what the integral f of x is, so I have to approximate using a Riemann sum. Right, so 1 over 12 is going to go in front. And I'm using a left Riemann sum, so my delta x here is 4, the left point is 23. The left point is 29, and then the left point is 36. Right, I use my calculator, I get 29.916, and that is my average value. All right, let's keep going. All right, so a lot of words. So word problem here. So between 1 and 4 on a weekday, speed of traffic is as such. This is my speed. And now I want to know the average speed between 1 and 4. Okay, easy enough. So 1 over 4 minus 1, right, those are my bounds. Integral from 1 to 4 of my speed. Right, now, personally, I put this in my calculator because I'm a cheater, but you don't have to. So we could evaluate this if we wanted to. Right, either way you want to do it, you could do it by hand, you could put it in your calculator. Either way, you'll get 65.5 kilometers an hour. So that is my average speed. All right. Now we're going to skip this next example because it causes all kinds of problems. And last one here. Okay, so I want to find the average value of my function without taking the integral. I have a piecewise function. So chances are you're going to use geometry. So think back long and hard to your geometry teacher, maybe thank them because you're using their stuff in calculus. You thought it would never pay off, but it is, right? 5, 6, if I can count. Okay, so what I want to graph, first of all, 3 minus x between negative 1 and 3. Right, so that is going to be 2, 3. All right, so that is, what am I doing? Going to cross there. And go up a little bit more. Okay, so here is one part of my piecewise function, and then at 6, this has a value of 6. So 1, 2, 3, 4, 5, 6 goes up to here and draw. Okay, so I also want to find this area. All right, so here's my function. I'm considering these areas, and I want to know the average value of my function along this interval. So I got to consider 1 over 6 minus negative 1 integral negative 1 to 6 f of x dx. Now this would be a huge pain in the butt to do because I would have to split this into 2 different integrals. So instead of doing that, I can just figure out what each triangle is in terms of area. So the area of my first triangle here is going to be 8. The area of my second triangle is going to be 9. I got 17 over 7, way easier than doing this analytically. All right, so doing it, literally doing it geometrically is always an option if you got straight lines. Okay, it works great for linear functions. And circles. All right, that's it. See you later.